and thank you, Zoom, for recording this. So my talk today is going to be an overall perspective of the challenges in the semiconductor industry. I thought this is a really cool topic to give an overview of, given that we always hear news cycles about the semiconductor supply shortage. And right now, a lot of companies are coming up with their own chips like Tesla, Apple, Google, a lot of names out there. So I have a quick presentation that I'll just screen share. Everyone let me know if you can't see my screen. Okay, cool. So the first thing I wanted to talk about is when we think about scaling with semiconductors, we often hear things like Moore's law or nanometer process technology. I think all of this can be a little confusing and overwhelming to understand. So the first thing I wanted to clarify is that there's a term in the semiconductor industry called a die. And what you see on the left here is what a single die is. It's essentially one chip that can serve many different purposes. In this case, this is actually the die of the Apple M1 chip that's used in their latest line of laptops. Now, that die is then packaged into a plastic composite, and it's soldered onto a printed circuit board, like you see on the right. So whenever you look at a motherboard or any of these printed circuit boards, those individual packages you're seeing are actually dies within those. So that's just one thing I wanted to clarify before going on. The next thing to understand is how those dies connect to the idea of scaling in the semiconductor industry. So this is a picture of a silicon wafer, and it's a wafer that's been processed completely through a fab, which is a fabrication facility. And what you see on this wafer are hundreds of these identical rectangles, essentially. And each of those rectangles is a single die. So after the wafer has been processed in the fab, what will happen is that there will literally be a machine that dices this wafer, cutting it up to make these individual die. And those individual die will then be packaged into chips, into circuit boards, and many applications after that. But one question might arise here, which is that how does the number of die on a single wafer matter, right? Why is that something that people care about? And I'd like to make the analogy of one wafer corresponding to, let's say, a single circle of pizza dough. So a single wafer has an associated fixed processing cost. The same way you might have a fixed cost in a bakery for making a single circle of dough. After that, the company's goal, any semiconductor company, their goal is to make sure that they can maximize the profit for that given cost of that wafer. And the way they can do that is by manufacturing as many chips as possible with a single silicon wafer. And so that's why you hear a lot of people talking about shrinking these chips down. The reason you want to shrink these chips is so that you can fit more of these die on a single wafer, and therefore you improve your cost efficiency that way. Now, that's only one part of the puzzle. Not only do you have to shrink these chips, but you also have to satisfy the consumers who want the same level of computing power or even more with these smaller chips. So that's why you hear about these smaller and smaller process technologies. When you hear companies like TSMC talking about 5 nanometer or 3 nanometer process technology, all that's referring to is the size of the individual features that they can fabricate on any one of these dies. So the smaller they can fabricate these individual features, the smaller each of those die can be, and therefore the more die can be fit on a single wafer for the same level of computing power and cost. And that's the main driver of this whole push to scale and this whole Moore's law shrinking that you've been hearing about in the news cycle. Now, the next thing I want to talk about here is the overall ecosystem in the semiconductor industry. We've talked about scaling, but that's really only the big level overview. There's also a very complex supply chain that exists within the semiconductor industry to make these chips actually function and be sold to the end consumer. So what I've shown here is again an analogy from the semiconductor industry to something like a bakery. So on the very left, we have the equipment vendors. These are companies that actually make the tools that are then used to fabricate these chips in those facilities. So these are companies like ASML, which is actually a Dutch company, Applied Materials and Lam Research, which are both based in the Silicon Valley Bay Area here. And these companies essentially make the ovens, if you want to take an analogy. They make the equipment that's then used by the bakeries to make those products. So at the next level, we have the foundries, which are the bakeries. The foundries include companies like TSMC and another company called Global Foundries. But you'll see here that I've also included companies like Intel and Samsung. And what these are companies that not only design the chips, but they also manufacture them. And so they're similar to foundries in that they have to occupy all of these fabrication facilities and really maintain that that manufacturing cost. So these companies will take the machines from those equipment vendors and use them in their factories to make those chips. And finally, we have the design companies, which I like to compare to chefs, the people who come up with the recipes and come up with the idea for the end product. So these are companies like Apple, NVIDIA, Qualcomm. You'll hear these companies referred to as fabless. And what that means is that they don't manufacture the chips. They just provide the designs for the chips, the recipes, if you will, and they pass it on to the foundries for them to actually fabricate it. So I just wanted to lay out this ecosystem before explaining some of the more interesting economic complexities of the semiconductor industry. So one thing you might hear a lot about semiconductor stocks is that they're very cyclical. So what I've shown here is the stock price of Micron, which is the company I worked at over the summer. They make memory chips, which is just one of a whole host of chips that are out there. But you can see that the curve for the stock price is relatively cyclical. Even though it rises over time, there's a very particular cadence to it, which is around 2 to 3 years. And the way this axis is labeled is really like the first two numbers are the year and the next two numbers are the month. So like 1311 is November of 2013. The reason I'm showing this is to sort of preface the idea that semiconductor stocks and companies are always cyclical in revenue. And the reason for this is that if we go back to this ecosystem, if we take something like Apple, right? Every single year, people in Apple, marketing specialists, will predict how many iPhones the customers will demand. They'll look at satisfaction from the previous iPhone and maybe use that to make some conclusions about X amount of iPhones being sold this year. Now, if we take a step back to the bakery level, TSMC, which makes the chips that go into the iPhone, they have their own marketing specialists that will say, okay, next year, we think Apple will give us this amount of contracts because we think there will be this amount of demand for iPhones. So there's another level of prediction that TSMC is doing. And just to give you an idea of this, they're not just doing this for Apple. TSMC makes chips for all three of those design companies here and many more. They're one of the biggest foundries. In fact, they are the biggest foundry in the world. So they have all of those predictors that are being assessed every single quarter, every single year, any time period. And at the same time, the equipment vendors like ASML and Applied and Lam Research, they're also doing the same kind of prediction. They're trying to see how many tools TSMC might require in the next year based on how many iPhones might be sold the year after, right? So it's a very long-term prediction model. And the problem with this is that none of these predictors are going to be right. There's always going to be some difference between what the end users want and what all of these predictors and all these models are predicting. And so you end up with two different scenarios. First, let's look at a case where all of these companies think that more iPhones will be sold than are actually sold. So what will happen in this case is that all of these companies will make too many chips. Apple will put in too many orders for chips, TSMC will manufacture too many chips, and the equipment vendors might sell too many machines to TSMC. But when the actual orders come in for the iPhones and they're underwhelming compared to the expected demand, all of the factories, all the fabs will suddenly slam the brakes on production. And they'll say, we're not producing anymore because there's no demand for it. Well, the problem is that the factories can't really operate at zero utilization. There has to be some overhead that has to be met with production. So they'll keep churning out a little bit of production there. And so you have an oversupply. And that drives all the chip prices down. So that's what will happen in a supply glut. Now, on the other hand, let's say all of these companies underestimated how many chips would actually be demanded out there. The problem with that is it's not easy to just ramp up production in the fabs. So let's say there are way more iPhones being demanded out there. It'll take a long time for TSMC to manufacture enough chips to actually meet that end demand from the users. So then we end up with a shortage, and then the prices go up for these chips. So you have this constant trade-off between oversupply and undersupply. And the reason there's a cyclical nature to it is because there's a lag time between what the customers demand and what the fabs are actually producing. And that's why we end up with this cyclical nature with a lot of these semiconductor stocks. Now, the final thing I'll wrap up with today is just an explanation for why there's been a COVID-19 shortage and why you hear about this chip shortage in automotive and other sectors. When the COVID pandemic hit, all the marketing specialists in these companies thought that because of this immediate temporary recession, that the demand for all these chips would go completely rock bottom. And they were completely wrong about that for two reasons. The first of which was that because people spent more time at home, they actually had more disposable income to spend on things like iPads, computers, TVs, what have you. The other thing is because people were at home, they depended more on electronic devices, as I'm sure you all can relate to, whether it's for work, like laptops, or for entertainment, or for games, whatever it is. So the actual demand was well above the expected demand for these marketing specialists. And so we have this lag time where none of these fabs are able to meet that demand for the end customer. And so you have this shortage, and it's reflected in the pricing right now, as you can see in this chart, but it's not really a great thing for these companies because they're so far from the actual demand that's out there. So I know that was a lot of information crammed into one presentation, but I hope it gave you some insights into how the semiconductor industry operates and some of the nuances associated with managing a capital-intensive industry like that. Unlike, let's say, a software industry where you can ramp up changes and ramp down changes much more quickly in response to demand. Thanks.